I'm Daniel Sadler. I'm a postdoctoral fellow here at University of Vermont. I'm in the Pespini lab. My main research focus is on how climate change and climate change-induced stressors are affecting organismal responses as well as ecosystem dynamics, specifically focused on the purple sea urchin and the community that they're a part of in the marine intertidal. So they're a really integral part of the kelp forest system, specifically off the coast of California and Oregon, as they're a key grazer and they influence kelp forest abundance. In fact, it was a part of the problem of why purple sea urchins are proliferating, so that is an issue at the moment. There's potentially too many purple sea urchins which are overgrazing these kelp forest systems, and part of that historically was the overhunting of sea otters. Now there's a second issue where there's another predator that's been influenced by climate change, where the sea stars of the California that predate on these purple sea urchins went through what's called this sea star wasting disease. So basically this disease caused them to fall apart, and it wiped out many of the species along the California coast. As soon as you form this urchin barren, there's nothing, it's just desolate wasteland because all the kelp has been grazed. So you just have urchins and this sort of rocky barren that's almost like the moon. And what we think we're finding at the moment is that the purple sea urchins are really resilient to thermal stress, to changes in oxygen, changes in pH, all associated with climate-induced warming. Now and in the future, they're going to keep doing well. So the more of these predators you knock out of the food web, the less there is to control these sea urchin populations from just proliferating and taking over these communities because they're not being kept in check. So what we found when we started heating these urchins up, exactly as you say, is when we have them at a higher temperature, there is this ability to acclimate to these higher temperatures and retain fitness. And how we measure that is basically we have them in a box, we stick them to the side, turn them upside down and wait for them to drop off, because that loss of sort of adhesion is a loss of ability to be able to survive and reproduce, because the function disappears and in real life they'll be more prone to predation and just being shifted into the currents as well. So it's suggesting that they can track with this temperature change, and they already have this really high thermal ceiling that they can reach, so they're probably going to be okay under climate change. So these guys are living at sort of 21, 22 degrees Celsius, and then when we increase the temperature there, they increase their absolute thermal maximum, which we were really surprised at, because these urchins are already very close to thermal limits we'd expect, because they're at really high temperatures down there compared to other urchin species. And they still have this ability to go higher and higher. In the most northern populations, there's this big sort of offset in what the genetic structure is likely to be and what is needed to be to deal with this enhanced climate change. And they're going to have a harder time. And we want to know the interactions between all of these to predict what will this ecosystem look like in 2050, 2100, based on climate models that we have now. And we can use these models to help with management regimes to say, oh, these organisms should be protected because they're more likely to experience local extinctions or population loss under future climate change, and we can use these models to help inform management and conservation. The two reasons to care is life is beautiful and you should enjoy it, whether that is in your back garden or snorkeling in the ocean. And two, we are part of that habitat, so if we keep it healthy, we keep ourselves healthy.